Hello and welcome back to The Effect. We're still talking about difference in differences. And in particular, we're going to be thinking about, up to now we've been talking about just sort of a before and an after. And if we wanted to talk about more time periods all at the same time, then we said, okay, yeah, well, we'll just add a set of fixed effects for time period, and that will allow us to account for the different levels of time in different periods. But we can actually get a bit more complex than that if we have multiple time periods to look at. We can do what's called dynamic difference in differences. Now, to make the terminology just as confusing as it possibly could be, if you're an economist, you might have heard this referred to as an event study. I use the term event study to refer to something entirely different. In fact, an entire chapter of the book that has nothing to do with this method, but that is what you might hear that term. But we're going to call it a dynamic difference in difference model, and here is what it is. Dynamic difference in difference says, okay, we got this idea with difference in differences. We have a control group, we have a treated group, and we have a before to after comparison. But why just compare all the befores to all the afters? Why don't we allow ourselves to make a effect that treats each after period differently? Let's say that I have my school teacher training reform program that goes into effect in 2012. Well, I can say, okay, well, if I'm doing my basic difference in difference, I can say, okay, compare everything before 2012, 2008, 2011, against everything after 2012, 2012 to, let's say, 2020. And that's my after period, that's my before, compare after to before. But why don't I say, well, hold on a minute. Why don't I say, okay, here's 2011, and I'm going to compare that 2011 to 2013. That's one difference in difference effect. And I will see this is the difference in difference effect of that policy, just comparing 2011 as before to 2013 after. And then I'll do the same thing again, 2011 to 2014, and then 2011 to 2015, and then 2011 to 2016, and then so on and so forth. And I can do it with different pre-periods as well. I can say, well, what's the effect in 2010? What's the effect in 2009, before the policy ever actually went into place? And what this will give me is it will allow me to say, okay, well, here's the effect of the policy 1 year after it was implemented, 2 years after it was implemented, 3 years after it was implemented, 4 years after it was implemented, and so on. I don't just have to have a single effective treatment. And why should I have a single effective treatment? A lot of treatments, especially those that go into effect at a particular time, take a while to get to do anything, or they do a lot at first and then fade out over time. Why should I force it to be the case that the same treatment effect applies in every single period? There's no particular reason to do that. So what I need is a model that will allow me to estimate this. It must allow me to say, hey, here's the effect of treatment in this period, and here's the effect of treatment in this period, and this period, and this period, and so on. And this turns out to be surprisingly easy to do. We just start with our basic two-way fixed effects model that we saw right here. We have a set of fixed effects for group, we have a set of fixed effects for time, and we have a treatment indicator that tells it that is 1 if you are currently being treated. That is that you are in a treated group in a post-treatment period. And it's 0 if you are not currently being treated. That is either if you are before treatment went into effect or in the non-treated group or both. In order to turn this into a dynamic treatment model, we just need to do one thing. We take that treated indicator and we just sort of interact it. We interact it with a set of fixed effects for time periods. So we say, hey, I'm going to take whether you are currently in the treated group, and I'm going to say interact that with being in the year 2008. So I have a variable that's 1 if it is currently 2008 and you are in the treated group. Now keep in mind the treatment has not actually occurred yet, but I'm still going to have this indicator for you being in the treated group in the year of 2008. Same thing in 2009, a interaction term between being in the treated group and being in the year of 2009. It's 1 if you're in the treated group in 2009, it's 0 for everybody else. Same thing in 2010. We'll skip 2011 because we need to have a reference group to compare everything to. We're going to continue on to 2012, a interaction term between being in the treated group and being in 2012, and then in 2013 and 2014 and 2015, and it looks sort of like this, right? So we have a bunch of different treated group indicators being interacted with year indicators, whether it is before treatment or after. I've left out one of those indicators. Notice that there is no beta 0 here. It goes straight from beta -1 to beta 1. That's because I need to have a reference group to compare everything to. I need to have a baseline year where I'm saying, hey, this is where I'm doing my 2x2 difference, because that's what this is doing, right? This is really doing a 2-period difference in difference many different times. And so I need to have my sort of baseline before period to be able to compare to. And this also ends up being the period that I compare to for the other pre-treatment periods as well. Now, when I estimate this, I get a bunch of beta coefficients, and each of those beta coefficients is just like a coefficient from a regular old two-way fixed effects difference in difference model. And so the beta -1 coefficient, for example, that would be the effect of treatment in the last period before treatment occurred. The beta 1 coefficient should be the effect of treatment in the first period after treatment occurred. And in fact, what you can do is you can graph out these coefficients to see how the effect changes over time. You might get a graph that looks like this. So this goes back to that Kessler and Roth organ donation study that I talked about earlier, where California changed the way that it asked people to become organ donors in 2011. And we are looking at the effect of that change in the way they ask people to become organ donors on organ donation rates. Now, before we found a negative effect of treatment, but maybe that's just because we are averaging together a bunch of different effects and we ended up getting a negative, but really one of them is positive or something like that. Let's check that. So here I have estimated that dynamic difference in difference model using that data. And what I see is this. First thing you might notice is that there is a point there on quarter 2, 2011 that has no confidence interval on it at all. What's going on there is that is my reference group. That is the one that I decided, hey, this is the sort of baseline last pre-treatment period that I'm going to say, right after this, that's when the treatment goes into effect. I'm going to say that this is my baseline, this is my zero, this is my rock, and I will compare everything to that. From there, we can see the effects that we get. If you look to the right of that point, you see 3 treatment periods in the post-treatment data. This is telling us how the effect is different in the different post-treatment periods. So in quarter 3 of 2011, we see a rather large negative effect of negative 0.02 that is statistically significantly different from 0 because that confidence interval does not touch that dashed line of 0. This is telling us that immediately after treatment went into effect, we saw an immediate negative drop of organ donation rates in California. We can also see how this effect evolves over time. If we look at quarter 4, we see that it's about the same. Maybe it's a slightly smaller negative effect, but in quarter 1 of 2012, it goes back down and it gets a lot less precise. So in this case, we don't see a lot of evolution of the treatment effect over time. What we are finding here is that once that treatment effect went into place, it just sort of immediately did its thing and stayed there. But that's not always the case. You will often find that some treatment effects do nothing at first and then slowly start to have an effect. And this might be something you might see, something that takes a while to impact things. So, for example, right now as I'm sitting here, the gas price has just jumped up very recently. What you often have seen in the past is that when gas prices go up, people start buying more fuel-efficient cars. And so we might expect that, hey, if we compared a place where the gas price jumped up by more, as opposed to one where maybe it stayed relatively constant, if you can find such a place, we might expect that cars over here are going to start to get more efficient, but it's going to take a while for people to buy those new cars. So we wouldn't expect the effect to be there right away, but if we allow it to evolve over time, maybe we would see some sort of effect. And in that case, we might see that the effect right after treatment goes into place is very small, but it gets bigger as time goes on. And if we force there to be just a single post-treatment effect, we would probably lose the effect that's actually there, and we would miss it. The interesting thing about dynamic difference and difference, though, is that we don't just have to look after the treatment. After the treatment is where the effect should be, but we also have these estimates before treatment goes into effect. Look at quarter 4 of 2010 and quarter 1 of 2011. These are both pre-treatment periods, and yet I'm estimating the effect of treatment. Why am I doing that? Placebo tests. Before the treatment goes into effect, there shouldn't be any effect of the treatment here. Right? If there is, that implies that prior trends has been violated, and thus parallel trends might be unlikely to hold. Right? Because what is this saying? This is saying I'm comparing 2 different periods where treatment was not in effect in either place, and I'm looking for whether the gap between the 2 groups changed. If it did, then that tells us that we have a difference in difference effect, except that there's no actual treatment going on. So if we found an effect, that means that those 2 groups were changing at different rates. Uh-oh. And in fact, we do see a little bit of that here. If you look in quarter 1 of 2011, you can see that the effect that we estimate is statistically significantly different from 0. This is telling us that we have an effect of treatment in a time period where treatment was not actually occurring. This might make us a little bit concerned about our parallel trends assumption. Now, in this case, the deviation is not very large, even though it is statistically significant. I don't look at this graph and actually get all that concerned about this particular study, although it's not a great look. And if you saw a large violation, if you saw a meaningfully large effect that we estimated, that would make us very concerned about our parallel trends assumption. So this dynamic difference and difference model does a lot of cool things for us. While still being relatively easy to estimate, it allows us to see how the effect of treatment evolves over time. So we can see whether the effect goes into play immediately, whether it stays strong and stays at the same level as it was, like we see in the organ donation case. Maybe it gets stronger over time. Maybe it starts out doing a lot right away and then fades out over time. That's entirely possible as well. We certainly saw a lot of those in the event study videos when we're talking about finance. A lot of finance effects you expect to go into play right away and then fade out. We can also look at the pre-treatment effects to see if they are non-zero. If they are non-zero, that's a big concern because they should be zero because there's no effect there. So if they're not zero, that tells us that maybe we have a violation of parallel trends. Now, something important to keep in mind is that just like with the other difference in difference models, this does assume that any treatment that occurred happened at the same time for everybody. Right? This model, at least as I've shown it to you, is not capable of handling if we have different treated groups that got treated at different times. For that, we're going to have to look at the next video. Hope to see you there.